Hello, thank you for tuning in to our ASU GSV live presentation. My name is Andres Oranje. I'm a Vice President for our Assessment and Learning Technology Research and Development Division at ETS, and I'm joined here by Karen McWilliams, who is the Associate Vice President for the AI Research Labs. Before we delve into some specifics, I want to spend a few minutes talking about where ETS is and where we're going. So as many of you probably know, ETS has for the last 7 decades plus supported learners mostly indirectly. And the way we've done that is, of course, through our research organization and building a lot of methodology for educational and psychological measurement, but also through our assessments that have been used for admissions, that have been used for licensure, for policy evaluations, and things like that. So it's a pretty broad spectrum. However, we're also at a point where we believe that our strength in those methodologies should really also be applied to help learners more directly, help learners get more insight into where they are on their learning journey and how they can reach their learning goals. And that can manifest itself in many different ways, including, we have pretty robust natural language processing engines that we've developed over the last 2 decades in speaking and writing. And so pulling more of the specifics out of that to inform learners is one of the ways that we want to do that. We also are looking at, building applications that are based on the fairly deep theory on learning progressions that we've developed, and creating some recommendations along the way. So we believe we have a lot of potential in our traditionally high stakes methodologies that we can really start expanding into the learning space and supporting learners more directly. Um, and we are truly motivated by our research base and our scientific underpinnings, and believe that we can do something that frankly most people cannot pull off. So the AI research labs were really created to accelerate that direction and to bring a lot of the hidden potential out to the world. So the core idea here is that the labs build off a lot of their existing basic and foundational research, and we continue to conduct new research, obviously. And that those labs develop prototypes and minimally viable products that are grounded in this deep understanding of user needs. We work with cross-functional agile development teams, and that can range from learning scientists, research scientists, design instructional designers, UX researchers, engineers, and developers all together to create these things. And the most important thing is that we continue to make good on our promise of being a research-based organization, and that everything that we do comes with a with a body of evidence of efficacy. And so that's in a nutshell where ETS is, where we're going, and the core motivation that we have set up the AI research labs and what we're trying to do. So Kara will now delve more into the details and give you an overview of some of the things that we're doing. Kara?
Thanks, Andreas. As we know, the EdTech field is saturated with solutions that claim to support learners and educators. However, few vendors have evidence to support the claims they make about the effectiveness and efficacy of their tools. In fact, many of the EdTech tools that come out on the market are gone just as quickly, leading to false starts and frustrations among educators, learners, parents, and other users of these important tools. We suggest that there are three primary gaps in the research and development process that contribute to these challenges in the EdTech space. The first is a lack of true user centricity. For example, in some cases, users are only part of the product development lifecycle, often very early in the beginning during ideation, and then very late stage during testing, and there's not an iterative co-design and development process with those users. Also, because of an often rush to market, some teams don't spend enough time in the empathize phase, truly getting to understand the user's journey, their needs, their pain points before beginning development. Where there are co-design partners, because of the difficulty engaging with users, sometimes we risk not having a representative sample rather than doing the hard recruiting work to make sure that the users we're co-designing with are truly representative of the users who will be engaging with the tools. And then there are sometimes inconsistent feedback strategies where there could be a breakdown between the user researchers who are working with users and the developers and making sure that that feedback is iteratively getting included into the development process. This last example really speaks to the challenge of siloed research and development teams and organizations. Where research and development teams aren't working in the same backlog, it really risks the user experience of a tool not being based in the learning science, a lack of full team engagement with the users to really understand their perspectives. It could even lead to a challenge among organizational cohesion if there's constantly disagreements between whether research features or development features should be prioritized on a backlog. And that misalignment can lead to reduced velocity on the team getting toward development. The third gap that we see is a product development lifecycle that does not always include research. Without that, we risk not having early effectiveness studies that both contribute to an efficacy narrative and support development. And then we can't have true integration of those insights early in the research and development process, or evidence to support users as they're making adoption and implementation decisions. And lastly, insights to really move knowledge in the domain space or in the educational technology research and development space forward. As a nonprofit with an expansive research and development division, ETS is uniquely capable of conducting research and development in a way that addresses these pervasive challenges that we're seeing in the educational technology space. The ETS AI Research Labs considers ourselves research-based, user-obsessed, and technology-enabled. Educators and learners are at the core of everything we do, beginning from determining our strategic priorities based on their needs, and we engage with them throughout the entire product development lifecycle, including once a tool is launched into market and studies we conduct with them following launch. When we're designing and developing tools and services that meet user needs, the labs focus specifically on the learning science principles that are proven to help people learn most effectively. And importantly, we follow a product development lifecycle that prioritizes not only the ongoing releases of technology, but also an aligned research agenda. This allows teams to make user and data-driven development and optimization decisions, and provides users with evidence of whether the solution is influencing the intended outcomes. I'll go into a little bit of more detail on these areas over the next few slides. The labs apply a user-centered approach, which is a common framework implemented in the design and development of learning tools. It puts the educators and teachers at the center of design decisions. Beginning with the empathize stage, where educators and learners share their journeys, experiences, pain points through ethnographic research, sense-making, system mapping, and other methods, user experience researchers are able to establish a view of the world from the user's perspective. In the labs, all members of an agile team participate in the empathize stage so that the perspective of the user is central to all research and development, not only the user experience. Once the perspective of the user is understood, teams work to synthesize the insights they receive from users and make sense of needs. And in the labs, we keep the educators and learners central in the define stage by validating needs definitions through user interviews and larger scale studies. Research and development teams are then ready to ideate solutions that will meet user needs through brainstorming sessions, building on the ideas of others, and other forms of ideation activities. Here's where the lab teams really apply learning science to the solution concepts and conduct co-design sessions with a representative sample of users. Throughout the prototype stage, from sketches, lo-fi to hi-fi wireframes, solution concepts are regularly tested with the community and target users and iterated on based on their feedback. It's throughout that prototype and testing stages that lab teams realize the benefit of all members having participated in the empathize activities, because then the perspective of the user is present in all decisions being made by all expert team members. As noted, in some educational technology organizations, research and development occur in separate parts of the organization, at best working collaboratively, but at worst risking silos. The labs have a unique organizational structure such that technology, learning and data science, user experience, and product development are all housed together under the same lab. Staff in the AI research labs are included in a single, cross-functional, fully dedicated, self-directed team, which means that they are working only on one project. Agile teams that are 100% dedicated to a single research and development effort enables not only complete focus on a discrete set of user needs, but increases the velocity of a team executing on their backlog by reducing external dependencies across the organization. As you can see from the slide, teams are made up of learning scientists, instructional designers, user experience researchers, AI, natural language processing engineers, data scientists and data engineers, user experience designers, and software developers. The number of each of these experts on the team varies based on the project, but there's always at least one individual representing each expert area. By having scientists, technologists, and user experience experts sprinting together and working in the same backlog, we achieve the application of a research foundation to the development of innovative technology. So rather than scientists throwing recommendations over the wall to development teams, capability, feature, and component prioritization occurs as a team unit, ensuring voices from all expert areas are heard. And where engineers and/or developers are required to make compromises in the development process, they do so with the input from the rest of the team to ensure that they're not compromising the integrity of the scientific foundation of the tool. While the labs follow a traditional iterative product development lifecycle framework of discovery, definition, design, development, deployment, what's unique is that teams implement a research agenda that is aligned with and complements the product development lifecycle. Often, research and development teams will conduct user feedback to support iterative design decisions. Scientists in the lab take that a step further by conducting comprehensive research studies with designs that are appropriate for where a tool is in the development lifecycle. Study designs and methodologies are less rigorous in the early stages of the product development lifecycle, for example, literature reviews, survey research on user needs, etc., and become increasingly rigorous as evidence of effectiveness and eventually efficacy are developed throughout the product development lifecycle. It's important to note that through the research and development lifecycle, inferences derived from results of those studies and the claims made based on those inferences are always defensible based on the study design, data collected, and methods of analysis. An increasingly rigorous research agenda implemented as part of the product development lifecycle serves two primary purposes. First, as part of the development teams, scientists in the labs are able to communicate timely insights to their teams such that they can be practically implemented in the backlog. In doing so, a tool is not only built on a foundation of research, but the design and development is continually informed by new evidence. Second, studies of EdTech effectiveness and efficacy are often conducted once a tool or solution has been in the market for some time. But by developing a body of evidence throughout the development process, educators and learners have information they need to make informed adoption and implementation decisions. They can have insights into whether the tool works, against which outcomes, for whom, and in what context before deciding to implement it. Such insights can reduce those false starts and frustrations that we discussed earlier in the presentation. Of course, the AI research labs want to conduct research and development that enables equity. User obsession in the labs extends just beyond the design and development process. Teams follow principles that help us build tools that advance the equity of education. There are four primary principles the labs follow to enable equity. One, We hire for diverse development teams, which enables different perspectives, values, and experiences to be reflected in the capabilities and prototypes that teams produce. Second, we're very strategic about the recruitment of our co-design and development partners, and this could be educators, learners, parents, individuals in the workforce, individuals looking for employment. The strategic recruitment of development partners allows us to capture the experiences and needs of a diverse user group, co-design solutions, and iteratively test and refine prototypes to contribute to the development of more equitable solutions. Thirdly, the labs focus on the development of inclusive data sets to train our models, which promotes the development of unbiased models, enabling more equitable AI-enabled solutions. We recognize that we'll probably never reach fully inclusive data sets, but it is always our priority to ensure that we're pulling in data from representative samples. The fourth principle is that we always conduct subgroup evaluations in the alpha and beta stages of development. Subgroup evaluations provide directional evidence of what we refer to as differential effectiveness and efficacy. And it also supports ongoing efforts toward the development of equitable solutions. Because if we see a subpopulation is being adversely impacted by the use of our tool or not having the benefits that other subgroups are, we iterate back, we co-design back with that group to understand why that group may not be realizing the benefits and optimize the solution until they are. I've just given a very high-level overview of how we apply some important principles in the labs and what differentiates us from some other educational technology organizations. What I'd like to do now is walk you through an example of one product that's in development in the labs to help highlight how we apply these principles in practice. Today, I'll be walking through the example of a product that we call Coconut, which helps English language learners speak with confidence. The lab team, in partnership with an ETS subsidiary in China, is developing a personalized learning application that helps seniors 1, 2, and 3 in China learn a range of skills and subskills to support English language proficiency and gain confidence in their ability as they prepare for the Gaokao assessment. You'll see through these examples that we have co-designed and developed with educators, learners, and parents in Beijing, that the tool was developed based on learning science principles, that the content was developed based on language learning research, and that the solution has been iteratively tested and refined with the target user group. As a digital learning tool, we are never completely done with development, so we will constantly be iterating on this tool, but I'd like to share some of the principles and where we've arrived today. About 9 months ago, the lab team engaged with 14 students in Beijing who were either learning English or who had recently learned English, and were either preparing for the Beijing Gaokao or had recently taken it. They also engaged with 6 individuals who teach English in Beijing and 4 parents of English learners. Through interviews and focus groups, the team was able to understand the needs throughout the value chain. Student personas were developed, so the team had a grounding to refer back to throughout the design and development process, and they had a frame of reference for who their users were and their needs. The personas were developed through an aggregation of all of the user data that we had combined from the interviews and focus groups with educators, learners, and parents. Now, because the number of students, educators, and parents was relatively small, though not for UXR standards, we did want to validate the needs that we had identified through that work. So a broader survey was sent out to 30 students to test some of the assumptions of the team around the student experience learning English. Results from that survey suggested that experience mapping, persona development, and the needs assessment the team had conducted was valid. And so they felt confident moving forward to the next stage of the PDLC. Learning scientists and language learning scientists on the team worked together to build a theory of action based on previous research and insights collected in discovery. Given that Chinese high school English learners need to develop their English listening and speaking skills for the Beijing Gaokao and other personal goals, and that the top 5 needs associated with that goal were identified, student scientists then identified components of a tool that may help students reach their goals. And these are things like learner choice, peer collaboration, targeted feedback. In that theory of action, they then identified the action mechanisms based on those components. For example, things like selecting topic areas of interest or being placed in a personalized learning path. And then the immediate, interim, and distal outcomes of the tool were well defined, like increased confidence in speaking and improved scores on the Gaokao assessment. Upon establishing a theory of change, learning scientists develop an end-to-end learning model made up of a core set of learning loops that include identifying gaps, targeted practice to close those gaps, receiving feedback to constantly improve, and reviewing and interpreting feedback and scores. The learning loops are applied to a variety of skills like vocabulary and sub-skills like word-level pronunciation, for example. Across the learning model, in addition to having those learning loops, there are important principles in there like metacognition, reflection, goal setting, etc., so that learners are sure to be engaging with principles that we know are going to help them learn. During learning model development, natural language processing scientists and engineers on the team are collecting data from the target population of users to build and train automated scoring models to be integrated into the tool to provide increased flexibility, efficiency, in reaching learners' goals. What you can see here is that lab teams engaged in remote user research sessions. Target users help the team move quickly from sketches to paper prototypes to lo-fi wires while validating the design choices at each stage. So what you see all the way on the left are some sketches that were co-designed with users on remote sessions. Users were actually asked to do some sketching themselves, as was the team in the labs. They collaborated on these sketches, combined some of the features, and came out with sketches that the users and the teams agreed were a good starting point for wireframing. Once the team was able to move toward paper prototypes that were created in Muralboard, we were able to do some very early stage UX and usability testing. So for example, what you're seeing here are the insights that were going to be provided to users. We would ask the users questions like, please explain what 22% means to you on this screen. We would then be able to understand firsthand whether they were interpreting the insights as intended, and where they weren't, what additional prompts or other ways to visualize the data would be most helpful. During this stage, the users in the labs who are located in Princeton, New Jersey, were able to understand the local context of Beijing better and include features and components in the paper prototypes that are more relevant to the local context. Obviously, it's much quicker and less expensive to iterate on designs and paper prototypes, so being able to engage with users at that stage really saved the lab team's time on building out the actual solution. After the co-design partners agreed that the paper prototypes were representative of what they believe would help them learn, or their students learn, or their children learn, the team was able to move on to lo-fi wires. Again, it's a relatively light lift and inexpensive to move to lo-fi wires, and we can quickly go back and test with the users to see, one, if we have implemented their paper prototype designs appropriately, but two, to understand if there were any gaps from what they suggested in the paper prototypes to the lo-fi wireframes. Scientists and instructional designers on the team are then able to choreograph a learning experience that is appropriate based on the user's needs and what we heard from them during the design process. So with the theory of change and learning model as a blueprint, appropriate embedded assessment and instructional content were developed, data hooks were built, and coding began. So instructional designers and language learning experts worked together to develop the embedded assessments down to the specific items, create the meta tagging required for personalization and automation, and then before even coding them into a solution, go back to the users, have them look at the item types, the assessment types, the task types, and make sure they would find them engaging and would help them learn and gain in their proficiency. What the lab teams don't want to do is build a test prep application for Gaokao, so we didn't want to only include items that are represented on the Gaokao. We wanted to include items and task types that were appropriate to help learners improve their proficiency and also prepare for the assessment. Users validated that the set of items and task types and assessments and instructional content that were being proposed would both be engaging, would help them learn, and would help them prepare for the assessment. Once the embedded assessment and instructional content were determined, it's very important that a data scientist work with a learning designer and the rest of the team to understand an intentional user data footprint. If we aren't intentional in the data hooks that we're capturing in the solution, we'll miss out on the ability not only to create personalization and automation in the tool, but to learn about whether the tool is effective, whether we are achieving efficacy, and more about how people learn in the most efficient and effective way. Upon the development of the intentional learner data footprint, the data flow could then be tested and coding could begin. We want to make sure that the data that are flowing into the lake and the warehouse are the same as what's being represented in the learner data footprint. So a lot of time is spent testing that. And again, importantly, where developers have to make concessions or have to prioritize for a version 1 release, they do so in collaboration with the data scientists, learning scientists, and instructional designers to make sure they're not making any compromises that will impact the integrity of the learning solution or create blockers for scientists to be able to do important studies that are required from a version 1 release. Again, this is one of the primary benefits to these fully dedicated teams that are focused only on this one project. What you can see here is that as the teams worked on the learning science foundations, the data footprint, the assessment development of the solution, it all came together and emerged in this tool. You can see here some of the components and mechanisms that were highlighted earlier in the theory of action, as well as critical learning science principles that have been demonstrated to improve learner outcomes. So for example, what you see on the far left of the screen is the student's onboarding flow. Immediately, we give students choice in the type of activities and the type of prompts that they'll receive based on their interests, their areas of expertise, what they want to focus on learning. That student choice helps to give learners agency over their learning. It also helps them to set goals, which is shown to really help learners improve in their proficiency as they reflect on their goal progress throughout their learning experience. Based on both diagnostic assessments of their speaking and listening, as well as information they provide during their onboarding flow about their student choice, there's automated personalization in the tool that helps put students on a unique learning path based on their needs and areas of interest. This will both help the efficiency of their learning, it will target their instruction, and it will help keep them engaged. The automated personalization of the tool gets smarter as the tool learns more about the user. Therefore, we can make sure to keep them engaged longer on their learning path to help them meet those goals they've set for themselves. You can then see that in our prompts, in our instructional activities, and our content, it is really based in language learning foundations. We have brilliant language learning scientists at ETS who have leveraged and conducted quite a bit of foundational research around how language learners learn most efficiently and effectively, and that is embedded in all of our instructional content and assessments. There are other features that we know users said they wanted and that we have responded to with learning science principles. So for example, learners have indicated when they're trying to increase their English proficiency on other apps in the market, they feel very siloed, they feel very individual, they don't feel connected to a network. We know that peer collaboration helps learners learn most effectively, and so features for peer collaboration have been built into the solution. This will both meet the user's needs and maintain the integrity of the scientific foundation of the tool. We also know that targeted feedback is both critical to users, but will also help them improve and meet their goals more effectively. And so we've had our language learning experts work with our learning scientists, instructional designers, and developers to make sure that there is personalized, targeted feedback where students can improve. Even if they get items right, for example, we'll want to provide information and prompts that help them understand why that answer was right to help their overall comprehension. Again, these are just a few examples for the purposes of time today, but I wanted to help you see how everything we talked about in terms of the principles of the labs and the process of design and development emerges in the final solution. As I noted, advancing knowledge in the language learning domain is critically important to ETS as well. We want to be able to share the knowledge that we gain from the research and development that we conduct. The research and development lifecycle implemented in the labs really enables scientists to conduct robust research on language learning to advance the field and improve the tools developed at ETS. So to give you a few examples of the research questions that scientists are asking, because we have an intentional data footprint, we can ask questions like, how are users engaging with this tool? Is the tool being implemented as intended? Are learners engaging with the tool as intended? If not, why not? What are other usage patterns? Is there efficacy related with those usage patterns, etc.? Then, because we have a theory of action that is the foundation of the solution, we're able to understand whether overall use of the tool is related to those intended outcomes that were defined throughout the theory of action development process. We're also able to think about things like, are the use of specific features, components, and/or capabilities independently related to outcomes? So can we disentangle whether peer collaboration is influencing those outcomes? And if so, should we include opportunities for peer collaboration in other areas of the solution? Looking at the specific contribution of individual capabilities and components allows for optimization of a tool moving forward that is data-driven and based on empirical findings. Also, because the team did the hard work to define these user personas, we're more able to effectively think about things like, do different user personas engage differently with the tool? And as we discussed earlier, is there differential efficacy of the tool among subgroups of users? If there is, we'll want to go back, consider why, and do some optimization. So these are just some examples of the research questions that the scientists on the teams will be asking of the data that come in from usage of the tool. And we look forward to sharing the research we're conducting on Coconut in future presentations. We have our first large-scale study occurring in the fall, where a broader set of users will be using the tool, at which point we'll be able to conduct these studies and contribute to the optimization and hopefully some of the knowledge in the field.
Thank you, Kara. Time to wrap up. I hope you enjoyed the presentation and that you have a much better sense of what we're doing in the AI research labs. Just to repeat and summarize, it's about three things. We're research-based, committed to the science and the research. We're obsessed with our users, and we're all about enabling the technology to help our learners meet their learning goals. Thank you so much for listening, and we will now gladly take any questions you may have.